Okay, so we're starting with Unit 2 under the Statistical and Econometrical series, and the topic is Probability and Distribution. Here is the list of topics that we have covered under this video that you'll go through. So now to start with, what is probability? See, it's basically a branch of mathematics, and you can say even statistics that concerns events and basically the numerical description of how likely these events are going to occur. The probability of any event is a number between 0 and 1. The larger will be the probability, the more likely an event is to occur. So probability of an event, which is represented as PE, is basically a number between 0 and 1 that represents the likelihood of that event, which is represented as capital E, occurring. That what will be the likelihood of that event to occur. Here is the table just to show the probability and its nature, and where the first column you can see are the events, and rest all the columns are showing the possibility between 0 to 1, that is between sure and impossible. So basically you can see that all of them are lying between 0 to 1. So here is another example where we have shown the probability of an event when we toss one coin, what happens, what are the possibility, and simultaneously in the second example or the table you can see that two coins are being tossed simultaneously. So in the first, if one coin is tossed, you can see that the probability of head is 5 and the probability of resulting it into a tail is 5. So there are equal possibilities if one coin is tossed. Whereas if two coins are tossed at the same time, then maybe on the first flip there can be heads on both the coins, whereas in the second toss or flip it can be head on one and tail on the other, and further on. It's just an example to show what is the probability when single coin is tossed and what are the probabilities or the results or the events when two coins are tossed equally. This is some DIY for you to observe and fill in the table, and you can yourself see what are the possibilities and how it results. Now let's get into a basic term that has often been used in probability, which is sample space, represented as capital S. So what is the sample space? It is the set of all the possible outcomes whenever you are conducting an experiment. Here I have taken the most common example like rolling a 6-sided die, where the sample space is the possibility or the set of all the possible sides, that is 1, 2, 3, 4, 5 and 6. These are the total number of the possible events that can happen. So it is basically the set of the all, and event is one of the subsets of this. So like we've just understood what sample space is, it is the possibility set of the all possible event. Now what is an event? It is any subset of that sample space S. So it represents a specific result, as we already saw in our last few slides, or can say a combination of outcomes. So it's just a subset of that sample space S. Now there can be different types of events in probability, like maybe the impossible and sure events. We just saw that probability lies between 0 and 1. So impossible is 0, like if today is Saturday, I've taken a very simple example for that. If today is Saturday, definitely tomorrow is going to be Sunday. So it's a sure event, possibility will be 1, and on the other hand, the impossible event which cannot happen, like if a coin is flipped or tossed, there's no possibility that we can get the head and the tail both at the same time. So the possibility will be 0. So it's an impossible event. Similarly, you can go through all the other types. I have explained them with simple, very, very simple examples so as to make you able to understand it very well. There are other types. You can just go through them. Each and every has been explained with a proper example. So after all the 4 types, we shall now go to the formula for probability. It's a very, very simple formula basically. So the probability of an event PE is basically the ratio of number of favorable outcomes upon the total number of outcomes. I've taken an example where you draw a card from a deck of 52 cards are there, so total number would be 52, and the probability of drawing a jack out of that deck is, there are the 4 jacks in one deck. So the probability will be, number of favorable outcome here would be 4 because the number is 4, and the total number of outcome is 52 because there are totally 52 number of cards in a deck. So it becomes 4 upon 52, or we can say 1 upon 13. It's that simple. Now let's get into a few basic probability rules. I've also covered this topic in detail in one of the other tutorial video of mine, and I'll just put the link in the description box. So the very first is the addition rule, which says that if A and B are 2 independent events, then their union would be the probability of event A plus probability of event B minus probability of A intersection B. Probability of A intersection B is basically the probability of both the independent events A and B happening together. So whenever you need to find out probability of A union B, or the addition rule, this is the formula being used. Here it's been explained with an example where there are 2 independent events, where at a local local language school, 40% of students are learning Spanish, whereas 20% of students are learning German, and 8% of students are learning both Spanish and German. So we can clearly see that probability of event A, which is an independent event, is 40%, whereas of B it's 20. And the union of A and B is 8%, and we can simply put them in the formula and calculate. So as you can see, it's been done for you. The result is 0.052. So it is basically the probability of student learning either Spanish or German. So how this is how it's been done in the addition rule, or using the addition rule. So let's move on to the next rule, which is the multiplication rule, that says that for 2 independent events A and B, probability of finding, if you want to find out the probability of A intersection B, then it is simply the multiplication of the probability of event A with probability of event B. So here is the example to make you understand better. It's a question that says that what is the probability of getting a 5 and then a 2 when there is a normal 6-sided die. So here the sample space means the all possible event, the set of all possible events become 1, 2, 3, 4, 5 and 6, all the 6 sides. So the total events will be 6. Now what is the probability of getting a 5? It can come once, so it becomes 1:6. Similarly, the probability of getting a 6, is the same. It can come once, so it becomes 1:6. Now applying the multiplication rule, so we'll multiply both the probabilities, and we'll get the result as 1:36. Therefore, the probability of getting either a 5 or a 2 with normal 6-sided die is 1:36, and both are independent events. So now the next is the complement rule, where it is denoted by, this is denoted by PA apostrophe. So the complement of an event is the event that does not occur when the original event does. Example can be, if the event is getting the flu, then the complement is not getting the flu. And it is expressed mathematically as PA plus PA apostrophe is equal to 1, or we can say probability of event A is equal to 1 minus probability of complement event A, which is PA apostrophe, and vice versa. As you can see in this picture also, out of the entire sample space, if we see that this encircled event A is all which is not its complement, or we can say vice versa, that complement of A is not what is event A. So when event A is excluded out of the entire sample space, what is left out is complement of A, or which we saw in the last slide is being represented as A apostrophe. Here small c has been taken for that. A simple example has been taken like on an occasion, if spending at most $100 or maybe less than that per transaction is the complement of spending more than $100 per transaction, just opposite to what is the main event is. So PA here becomes spending at most $100. We have taken here and put in the condition in the form of the equation. So P under bracket at most $100, that is the main event. Complement would be, at most would be the main event, which is PA, and more than $100 would be the complement. So simply put in the condition in the equation and the result comes out to be 0.7. So the probability of spending at most $100 would be 0.7. So here are the most common examples where the concept of probability is applied and the result is worked out. Let us see one of the most common example that we often see in our exams and tests, most commonly found example of where the probability is applied. So here, out of the total 6 pillows in a bed, 3 are red, 2 are yellow and 1 is blue. Now we have to find out the probability. If we randomly pick, that what is the probability of randomly picking a yellow pillow? And I am sure after explaining it so much that you very well know that is the common formula will be used, that ratio only which we worked out earlier, that the probability will be equal to the number of yellow pillows, that is 2 in number, divided by the total number of pillows, that are 6. So it becomes 1:3. These are the types of probabilities: the concept, classical, the empirical, subjective and axiomatic. So in the end we can only conclude that the concept of probability helps us to make informed decisions, better decisions, certain decisions, because it provides a mathematical workout, a framework to quantify the uncertainty. So we can just find out what is the best out of the rest in situations where the outcomes are not deterministic or are not being easily found. So that is where the probability can be really useful. Okay, thank you.